Hi, today we're going to learn about summation of arithmetic and geometric sequence. So we're going to do summation. So basically summation is, if you were to look at this weird shape, this is called a sigma. This whole thing is called summation notation. So this is your nth term. So this is your n formula. So you have I square, and then this is where you start at 1, and then this is where you end. So what your summation notation is adding all the numbers to the limit. So here our formula is I squared, right? So when we plug in our first term will be 1 square. That'll be our first term. And then our second term would be 2 square. And then our third term is 3 square. So do you understand how I got 3 square? I'm plugging I with I with the term. So we start at 1, 2, 3, 4, and then we end up at 5. So what we do is we add up all these numbers, and then this should give us, this whole thing should give us 55 when you add all the like terms. So this is called a partial sum because we have a limit. Sometimes you will have infinity, right? You'll have an infinity. So this is called a infinite summation, and this is called a partial sum. Partial sum. Yeah, partial summation. Because this has a limit and this goes to infinity. And then there's formulas, so let's go over formulas. So this should be a review. So to find the nth term of a rhythmic sequence is an equals first term plus difference n minus 1. I went over this over series of geometric and arithmetic sequence. So if you want to review that, you can check out that video. And then the partial sum of an arithmetic sequence is Sn equals first term plus nth term over 2 times everything by n. So that's this partial sum of a rhythmic sequence. And then for a geometric sequence, the partial sum of a geometric sequence is Sn equals first term 1 minus Rn over 1 minus R, and then the sum of infinite, where it goes to infinity, like this one right here, is Sn equals first term minus ratio. So let's start doing problems. So the first question says find the sum of each arithmetic sequence. So we know that it's arithmetic. So first, what I'm going to do is write the nth term of an arithmetic sequence. So an equals first term plus d n minus 1. Okay, so I don't know the difference. So we have to find out the difference. So first we got to find our first term, second term, and third term. So first term is so we start at 1 and then we end up at 12. So it would be 6, 1 minus 9. So that's negative 3. Our second term is 6 times it by 2 minus 9, and that should give us positive 3. And then our third term is 6 times 3 minus 9, and that should give us 6 times 2 is 12, 10, 11, 12. 18 minus 9 is positive 9. So remember how to find the difference. You do A2 minus A1. Okay, so we know it's arithmetic, so let's find the difference. So A2 is 3 minus a negative 3, right? Because A2 minus A1. So that is positive 9. So our difference is 9. We don't have to do A3 equals A3 minus A2 because it already tells us it's a arithmetic sequence. So the difference is 9. Good. So now we could just put it back in this formula. So AN, I'll put it right here. We know our first term, which is negative 3, right? That's our first term. Plus difference, which is 9. And then we got to find, we don't know what n is. Okay, so the goal, we got to find the nth term. I want to find our last term, A12, sorry. I want to find A12, right? So let's find A12. So its first term, which is negative 3, plus difference, which is positive 9, and then 12 minus 1. I got it from this formula, right? The nth term of arithmetic sequence. So let's simplify. So this is A12 equals negative 3 plus 9. 12 minus 1 is 11. So that's negative 3 plus 99, which is 66. Oops. So that is our 12th term. So now let's use the nth term of a partial sum of arithmetic sequence. So we're going to use this formula. Sn equals first term plus nth term divided by 2 times it by n. So I'm going to use it says find the sum. I got to find S12, right? That's our last term. So we're going to use n equals 12 for this one. So first term is, we know that one is negative 3. And then we know the 12th term is from here, which is 66, divided by 2, and times it by 12. And then if you do all the work, you would get S of 12 equals 360. This is your final answer. So what we're doing is, like, we found the first term, the second term, the third term, and then you'll keep on going until you find the fourth, the fifth, the sixth, all the way to 12, right? And then you add all those terms, and this should give us 360. We are using this formula because it'll make it much easier, because you don't want to keep on adding and adding those long numbers until you get 12, right? So there's a formula we can use, but first we had to find the 12th term, because we had to find, the 12th term. And then, so we had to use to find the nth term of a rhythmic sequence. Okay. Let's do this one. So we're still going to find the sum of each rhythmic sequence, so I'm going to clear the board. So let's say you're given 1/2 plus 3/4 plus 1 plus 5/4 plus etc., etc., etc. until you go to the fifth. So this is our first term, right? That's our second term. This is our third term, etc. Okay, so we got to find the sum. It's the same. Find the sum of each arithmetic sequences. So we got to find the sum of this, right? And we know it's arithmetic because that's what it said, and that's what it said. This is arithmetic. So we got to find the difference. First step, I'm going to find the difference, right? So I'm going to do a2 minus a1, so 3/4 minus a1, which is 1/2. Multiply this top and bottom by 2, so that's 3 minus 2, which is 1. And then 4, that's 1/4, so our difference is 1/4. Now what I'm going to do is I'm going to find 2, 3, 4, 5. Okay, we know. So what do we know? We know that our first term is 1/2. Our nth term, our last term, is 5. But we don't know what nth term is. We don't know how long it keeps on going. We don't know our limit, right? We don't know our limit. We know it starts at yeah, we don't know our limit. What else do we know? We know, so if we know those two numbers, let's use the nth term of of arithmetic sequence. So we're going to use this formula. An equals first term plus d times n minus 1. So our goal is to find the nth term, so an equals, we know the first term, which is 1/2. We know the difference, which is 1/4. And we don't know what n is. That's our goal. Remember, we said that our nth term is 5. Our last term, that's what it means. Our last term is 5, but we don't know what n is. So that's our goal, is to solve for n. So 5 equals 1/2 plus, plus 1/4 times n minus 1. So that's 1/4 n minus 1/4 plus 1/2 equals 5. I want to get rid of the 4's, so I'm going to multiply everything by 4. So that gives me 20 equals 4 over 2 is 2 plus n, because the 4 cancels, right? And then negative 1. So you're left with 2 minus 1 is 1 plus n equals 20. Subtract 1. Subtract 1. So n equals 19. So good, we found the n. So we got to find, so our limit is 5, right? That's our limit. We got to find, they're not asking for a formula, we just got to find the sum of the limit. The sum of the this is a partial sum arithmetic. So it's this formula. It's this one. We're going to use this formula. This is a partial sum of arithmetic sequence. So we're going to use this form. Sn equals first term plus nth term, an term, divided by 2 times it by n. So we know that our nth term is 19, so we're going to say S19 equals first term, which is 1/2, plus a nth term is 5, right? Our nth term is this one. It's 5 divided by 2 times it by n, which is 19. When you do all the work, S of 19, the sum of this summation is 52.25. Yeah, so this is your final answer. So yeah, when you do the work, I'm not going to do it because I've already done it, but when you do the work, you're going to get S of 19 equals 52.25. You know what, let's just do it and just do the work. So this is 1/2 plus 5. So I'm going to get the common denominator, so this is 2. So this is 10. 10 plus 1 is 11/2. So 11/2 divided by 2, that's compound fraction, so I'm going to multiply everything by 2. So that gives us 11/4. And then don't forget about this 19. And then that's how you get 52.25. Okay, now we've done arithmetic, so let's do some geometric summation. So let's say it says find the sum of each infinite. So what infinite means is it's going to go to infinity of a geometric sequence. So if this is a geometric sequence, it must have a common ratio. So this is our first term and this is our second term. So second term, its ratio is second term. Remember, ratio is second term divided by first term. So it's 0.09 divided by first term, which is 0.9, and that should give us 0.1. So now we got to use the formula for the infinite. So it's going to be this equation, right? The sum, it's going to be this one, S of n equals S of n equals first term minus ratio, right? So let's use that formula. S of n equals first term minus 1 minus ratio. So we know that the first term is 0.9, and then 1 minus the ratio, which is 0.1. So that should give us 0.9 divided by 0.9. And then that should equals 1. So the summation is just 1. Yeah, so we don't know what we know that we could just leave it as S of n because it goes to infinity, right? There's no limit because it's infinite. Let's try another one. So let's say you were given, I'm going to clear the board. Same rule, find the sum of each infinite sequence. So, but let's say we were given this one. Now this is in summation notation. So it goes from infinity to I. So the first term, we start at 1. And then this is our equation. So 6 times 0.1 times it by I. Raise it to the I, not times. So first we got to find the common ratio. But to find the common ratio, we got to find the first term. So the first term is 0 times 0.1 raise it to the first power. That gives us 0.6. The second term is 6 times 0.1 square, and that should give us 0.6 as well. No, it's 0.06. They're not the same thing. So ratio, the common ratio is A2 over A1, right? A2 over A1. So it's 0.06 divided by A1, which is 0.6. And that should give us a common ratio of 0.1. So this is infinity, so we're going to use the formula S equals first term minus 1 minus ratio. So let's just, we know the first term, which is 0.6, minus 1 minus the ratio, which is 0.1. So this should give us, the top should give us 0.6 divided by 0.9. And that should give us 0.66 or 2/3. They're the same thing. Good. So, and then our last problem says, now we're kind of like going backwards. It says write each geometric series in summation notation. So we got to make it look like, whoops. We got to find our I, our nth term. We know it's write each geometric series in summation. No, okay, so let's look at this. So it keeps on going dot dot dot. So that what that means, it's going to go from infinity. So when it's like dot dot dot, that means it'll keep on going. So we know it's from infinity. So it says we also know it's a geometric. So it must have a common ratio. So to find the ratio, you take the second term divided by the first term, so 1.5 divided by negative 4.5. So that gives us negative 0.33. Okay, so we found the ratio. Now what we got to do is find the nth term. We got to find we got to find the nth formula, right? We got to find this equation, the nth form. So the nth formula for the geometric is first term times ratio times n minus 1, right? That's this one formula. This formula right here. So to do that, we know we can find it because we have the first term, which is negative 4.5, and we know our ratio, which is negative 0.33, and then raise it to the n minus 1. So that's our formulas for the nth term. So our nth term is negative 4.5 so it's going to look something like this. Okay, but we don't know what our nth term. Let's play the guess and check game. So let's try n equals 1. So when n equals 1, n minus 1 is 1 minus 1 is 0, right? So anything to the 0 power is 1, and then times it by negative 4.5. So that gives us negative 4.5. So that's our first term, which is true, is negative 4.5. So we know that n starts at 1. So our equation should look something like our summation notation of a geometric should look like this. Where n equals 1 and the nth is negative 4.5 times negative 0.33 raise it to the n minus 1, and it goes from infinity because of this dot dot dot. So that's the end for this section.